Hello, my name is Ashley Ford, and this is my Math Chapter 8 project for Mrs. Wetmore's class. For this first equation, we're going to start by looking at the coefficients and the highest degree, if it will focus, please, to get the end behavior of this graph. So here we have this is the coefficient, and it's positive. And then we have the highest degree, which is even. So with positive and even, we can take a guess that the end behavior of the graph is going to look something like this. Rise left, rise right. From there, we're going to take all these degrees and add them up. Anything to the power of 1 is itself, so we can keep that there. And so then once we get 2 plus 1 plus 1, that's 4 minus 1. So we're going to have 3 turning points here. Now to figure out what the x-intercepts are, we're going to need to set all of these here equal to 0 to find out what x is going to be. Like so. So once we run through this, we're going to get that x equals 2. Just add 2, x equals negative 3, because we're just going to subtract 3, and x equals negative 5, so just going to subtract 5 and subtract 5. And so then we can put these points in over here, negative 5, negative 3, and positive 2. However, positive 2 has an even degree, which means that it's not going to pass through the point. It's just going to touch and then rebound. And these two are going to go through. So we can assume that if the graph is rising to the right and to the left, it's going to look a little something, little something like this. First problem down. So if we do the same thing we did up there, add in these ones for placeholders, then we find that the leading the coefficient is negative, and the highest degree is odd. So the end behavior of the graph should look a little something like that. And the amount of turning points, 1 plus 1 plus 1, equals 3 minus 1, 2. Then we set all of these equal to 0 again to get that our zeros are, there are our x-intercepts, so we'll just put them on the graph. And so our end result looks a little something like this. Now we're moving on to lesson 5, which is making equations out of graphs. Let's start by looking at the x-intercepts. This one just touches the x-axis and doesn't go through, so we know that this one's going to have an even multiplicity. And this one passes through the x-axis, so we know that this point right here, which appears to be at 2, is going to have an odd multiplicity. Now we know that these points here, negative 3 and 2, are going to have the inverse sign in the equation. So we can just say that y equals, or well, f of x, if you want to be specific. So f of x equals x plus 3 squared x minus 2. There we go. And so now we want to find the a value, and we can do that by setting y equal to 0 and seeing what we need x to be in order to get that. Okay, so after working through that, I meant x, sorry. And after working through that, we get that 9 equals negative 18a. We divide that by negative 18. And we get that a equals negative 1/2. So then the full equation, which I'm going to write out here. Sorry for all the jump cuts. I'm just trying to keep this under 10 minutes, and it's running kind of long as it is right now with these first 3 problems. So I'm just going to write that out, and then we'll see the final product. And there we go. That is the final equation. F of x equals negative 1/2 x plus 3 squared x minus 2. Ta-da! Now we're going to move on to lesson 6, which is dividing polynomials. And for this one, I'm going to use synthetic division. First, we need to write out the coefficients of the dividend here. So that would be 1, -4, -5, and another. Wait, no. We can combine like terms here. Sorry about that. That's negative 5x plus x. So that would be -4 again. And then we need to figure out what makes the divisor equal to 0. So we need to set x plus 2 equal to 0 over here. And x equal -2. So then that goes over here in this little box. This gets carried straight down. It's 1. So we multiply that by this right here, -2. We get -2 right here. So then that gets us -6. Gets us -6. And then we multiply that by -2. And that gets us 12. Then we add these two. That gets us 8. From there, we write these as coefficients with 1 less than 1 less exponent. And then we put this 8 over x plus 2, and there we go. So for this next one, I am going to use long division. So I'm just going to work this out like you would a normal division problem, just with polynomials, and the final result will be... So after working through all of that, starting over here and subtracting 2x squared, or 2x cubed, sorry, and then we go all the way down the line, we get... Oh, this thing will focus. Really sorry about that. There we go. Then we get the answer is x squared plus 2x minus 2. Yep. And we have a remainder of 3. So the final equation will look something like this. And there we go. Now we're moving on to lesson 7, the final lesson with these last 2 problems, dealing with special factoring cases and the rational root theorem. So starting off, let's look at this cube problem, this cubic problem right here. Since we know both of these have to be something cubed, let's start by finding the cube root of both of these numbers right here. So now we have our a values and our b values. And then we just need to plug it in to find the difference of these 2 cubes because we're subtracting. And then we'll get our answer. And so our final equation should look a little something like 27x cubed minus 64 equals 3x minus 4 times 3x squared plus 3x times 4, which can be simplified to 12x. And then plus 4 squared, which can be simplified to 16. There we go. That's our final equation. Okay, so for this last equation, p should be factors of 20, this last term over here, and q should be factors of 1, the leading coefficient. So these right here are all the possible factors. but we're going to run them through to see whether or not they're equal to 0 or not. Oh, right, all these factors can be positive or negative. So after doing all that work, we find that -2 and -5 are roots of this equation. Sorry if this ran a bit over 10 minutes. I tried my best to condense it all with all the jump cuts and whatnot, but there's my Chapter 8 project.